Okay, so we're going to look at linear inequalities today. You will have two more sessions on linear inequalities. Okay, so today it will be basics. And then
Yes, sir.
The next two classes will also be basics. Maybe I'll follow it up with a session for only problem solving. Okay, so maybe in 4 sessions, we should be able to understand linear inequalities. Okay, did you study linear inequalities as part of school studies?
Yes, sir.
So
I
you,
mean, uh, I was taught like it was basically the same as equations, but with the inequality signs, and I've also learned the upper and lower bounds
oh,
for
okay, so
rounding.
okay, you're familiar with the intervals.
Yes, sir.
Oh, that will be good. So then I think okay, we'll go through today's session. Then I'm hoping today's session should be super easy for you. And then depending on how it goes, so the next class I'll try to speed it up.
Yes, sir.
Yeah. Okay. So linear inequalities in one variable. Okay, so you have some real number which is not equal to 0, and then these linear inequalities will look like this. Okay, so you either have ax plus b less than 0. Okay, where b is again another real number, or you can have ax plus b greater than 0. Okay. And then such inequalities are called strict inequalities because we are saying either less than or greater than 0. Okay, so just some terminology. And you can also have ax plus b less than or equal to 0. Okay. Or ax plus b greater than or equal to 0. Okay. You know what these inequalities are called? Again, not really important, but do you know?
I'm not sure about the word, but it's opposite of strict inequalities.
Okay, yeah, it will be followed up with inequalities. They're called slack inequalities because you are allowing that less than or equal to. Okay, so if you don't have that equality, they're like strict inequalities. Again, it's good to know, but I think we understand, right?
Yes, sir.
Yeah. And then few other things. Linear inequalities in two variables. Okay, so we have just seen linear inequalities in one variable, how they look like. Here we are looking at linear inequalities in two variables, x and y. Okay, so supposedly a is the coefficient of x and b is the coefficient of x because we want those variables to be meaningfully represented. We don't want that a and b to be 0. Okay, so that is why a is not equal to 0, b is not equal to 0. So they will look something like this. So if you take another real number, ax plus by is less than 0, sorry, less than c, and ax plus by greater than c. Again, these are strict inequalities. And then the slack inequalities will look something like this. Ax plus by less than or equal to c, and ax plus by greater than or equal to c. And these are slack inequalities because we are allowing equality. Then, okay, so double inequalities. Double inequalities are nothing but your inequalities. You are trying to kind of represent both the less than and then greater than or a combination in one go. Okay, so they look something like this. So if a and b are some real numbers, if you assume that a is less than b, so here it says that x is greater than a uh, and x is less than b. Okay, you understand this, Sidhu?
Yes, sir.
So, and then you can have a variation. Okay, so when you take the lower bound, so this time the lower bound is included. Okay, the upper bound is not included. And then in this case, your upper bound is included and the lower bound is not included. And here both are included. And you know how to write the intervals? using that brackets, open bracket, closed bracket. Did you learn about those, Sidhu?
I believe no, sir.
No? Okay. So in this case, if you take A and B are real numbers, suppose A, B, if they belong to real numbers, if you assume A is less than B, I think it's something that you know from like school days, right? If you take two real numbers, there are infinitely many numbers, right?
Yes, sir.
For example, if you take 2 and 5, between these two numbers, there are infinitely many numbers. Okay. So when you try to represent a subset of real numbers, okay, you can do that by using the lower bound and upper bound. Okay, for example, here A and B. Suppose X is between A and B, but neither A is included nor B is included, then they represent by using this open brackets, the normal ones, A, comma, B. So that's a notation for interval. Okay, it's as same as this. Okay, so they are same. And similarly here, because the lower bound is included, you put that square bracket A and then B, and then B is not included, so you have that open bracket. So these two are same. Okay, so the same representations. But again, I think I'm making a mistake here. I should actually say X belongs to. Okay, so because X belongs to, because there is no X here, right? X belongs to this set. So these things are taken as sets, right? So these are sets, subsets of real numbers. Okay. Again, for CBSE 11th class students, now I've actually put videos on my channel on sets. You should watch that.
Yes, sir.
Okay, and then here A is not included, but B is included. And then here both are included, so you use a square bracket on either side. Okay, so these two are like, I mean, you can either go with this representation or you go with this representation. So both are same. Okay, so that's nice actually. Okay, now this is, I'm hoping you know these as well. Some kind of rules for handling inequalities. So if equal numbers are added to both sides of the inequality, the sign of inequality remains the same. And if you subtract from both sides also, the sign of inequality remains the same. I mean, if you just take numbers, suppose I have 5 greater than 3, suppose. If I add both sides, let's say a number, suppose I'm adding maybe 4. Okay, if I add both sides, then what will happen? The left hand side I have 9, the right hand side I have 7. I think this the fact that left side quantity is greater than the right side quantity still holds good. Okay, so nothing really happens to the sign of the inequality if you add the same number on both sides. The same thing goes when you subtract a number from either side. Suppose, okay, so I subtract, for example, 2 on both sides. So then what will happen? I have 3 here and then I have 1 here. So the inequality is still valid. So the left hand side is still greater than the right hand side. Okay, so you're okay with this, Sidhu?
Yes, sir.
And now, if each side of inequality is either multiplied by a positive number or divided by a positive number, and again, the number that, since we are saying positive number, you're not dividing anyway by 0. For a moment, I thought 0. The sign of inequality doesn't change. Okay, so if we continue the same example, let's say 5 is greater than, I think this time, since I want to divide, maybe I'll take some convenient numbers. So let's say 10 is greater than maybe 6. We know that. Okay. So if I multiply by, let's say 2, so the left hand side becomes 2 and the right hand side becomes 12. So the inequality sign will still remain same. But on the other hand, suppose if I multiply by -2, suppose. Okay, so if I multiply by -2 on both sides, now whether this inequality will, what do you think? What will happen here? The left hand side I have -20, the right hand side I have -12. Now which is greater?
-12.
-12 is greater. So now I cannot say that this is still valid. Okay. So the sign of inequality reverses. In such a case, the sign of inequality actually reverses. So -20 is actually less than -12. Okay. So I think I'll back it up, these things. So however, if each side of an inequality, if it is multiplied or divided by a negative number, the sign of inequality reverses. This is important to keep in mind. Okay, so I mean, easy to understand, but I think when you do problems, yeah, we need to watch out for this. Okay.
Yes, sir.
Yeah. Okay, so I think I will pause for a minute. It's an easy problem, so I want you to try a minute. Okay, so I'll pause here.
So
It
can be either 4. It can be either 4, 3, 2, 1, 0.
Okay, will 0 be part of the answer?
Sorry, no, sorry. It can be 1, 2, 3, or 4.
Yes. Okay, so 1, 2, 3, 4, because we are saying specifically x is a natural number. Very good. Okay. So here 45x is less than 225. And then that means, okay, you know what this symbol means?
Values between x.
No. This symbol, the one which is here. This means if and only if. That means these two statements are equal. Okay, if this is true, then this is true. Or this is true, then this is true. Or you can write, sometimes I think they write or. Okay, again, I mean, if you want to write a solution as part of your schoolwork, okay, but if you are taking SAT, you don't really need to do all this work. Okay, so you are interested in quickly getting down to the correct option. Okay, but this is also something that you should learn. So
Yes, sir.
Here, because we are dividing by a positive number, the sign of inequality preserves. So x is less than 5. Because x is a natural number, then the solution set is only 1, 2, 3, 4. Okay, does the answer change if x is an integer?
Yes, sir.
Okay, so then what happens to the solution set?
Because x is an integer, it could also be a negative value, so the inequality sign could reverse.
Fantastic. So it could include that 0 and then all the negative values. Very nice. Okay, so now x will be all those negative integers plus 0 and then these 1, 2, 3, 4 as well. Very nice. Okay, again, I'll pause for a while. Try this again. Okay, so what is your answer before we discuss?
The answer could be either -1, -2, 0, 1, or 2.
1 or 2. And then do you have like values less than -2 as well?
Yes, sir.
No, less than values, the integers which are less than -2, are they part of the solution?
Yes, sir.
Yes, very good. So you have this, and then here, I think I can take -5x to the left-hand side, but there is a mistake, isn't it? I made a typing mistake. This should be less than. Okay, so that should be less than. And -4, I can take it to the right side. Okay, and then we have 2x less than 6, and then x less than 3. So very nice. Okay. Now the question, does the answer change if x is a real number?
Yes, sir, it does, because since it's a real number, it's supposed to be positive.
No, supposed to be positive only? No, no. What will be the answers if it is a real number?
1 and 2.
Only 1 and 2? But between 1 and 2, are there no numbers if x is real?
So it is all the numbers between 1 and 2 inclusive.
Exactly. All those, you might have studied about rational numbers.
Yes, sir.
How about irrational numbers? Did you study about them?
Yes, sir. I do not remember a lot.
But okay, you know that there are numbers like rational, irrational,
Yes, sir.
right? Yeah. So all those numbers will come. There will be many, many numbers. Okay. So any number less than 2 will be our answer. Okay. So now this is how you represent it. Okay. So we are using open bracket on both sides because 2 is not included. So here you are just learning the interval notations. Okay. So maybe I think I see that you can actually solve today's problems. That's very, very good. It's just that you are learning these notations. Okay. So maybe that should be the only value add today. Okay. So minus infinity, that means minus infinity, comma 2. That means all the numbers less than 2. Okay. So all the decimal values, okay, all such numbers like, I don't know, minus root 2, minus root 5, all those irrational numbers will be part of the solution set. Okay, now another thing, whenever in any problem, if they don't mention anything about what values they're expecting, we always assume that x is either the real number set, x belongs to real number set, or a subset of real numbers. Okay. And okay, so try this. Okay, so you can tell me your answer and then we'll discuss.
So I believe the answer is all the numbers greater than -1.
All the numbers greater than -1. Okay, I think you're right. Okay. So
I
here,
put that in notation as x belongs to
yeah.
curly bracket infinity comma -1.
No, it's not curly bracket, the open bracket.
Oh, sorry, yeah, the parentheses.
So when you actually use the curly bracket, it actually says that whatever you literally mention the numbers, only they are the solutions. Okay, so yeah, these are the notations that we need to learn. Understand?
Yes, sir.
So if you use the curly braces, that's called a roster form. It says that, okay, whatever you literally list down the numbers, only those become the solution set.
Yes,
Okay.
sir.
So here again, -7x, I can bring it to the left-hand side, and then 4 to the right-hand side. And again, I think you know this, right? If you switch sides, the sign will change, but the inequality sign here doesn't change because you are adding and subtracting. And then -2x is less than 2. Now here, we are dividing by -2, and then you carefully used reverse the sign. That is good. So that should become x greater than -1. Okay, so dividing both sides by a negative number, -2, reverses the sign of inequality. Fantastic. So x belongs to -1. Okay, so here you need to use this open bracket, not a curly braces. Okay, very good.
Sir, I haven't switched the sign.
What is that? Actually,
Oh, okay. I told the answer is x is greater than, but in my book I still wrote it as x is less than. Whoops.
Okay. So you said the correct answer, but in the solution
I
you
wrote
have
it
less
wrong.
than 1. Okay. Okay, your mind knows better. Okay. So you understand the sign of inequality should reverse here. You're
sir.
dividing by a negative number. Okay. But you understood.
Yes, sir.
Okay. So, and again, this is another thing that you're going to learn. Have you seen representing solution sets on a real number line?
Oh, yes, sir. I have done this in the school. The basics I know are, if it's a strict inequality, you do a hollow circle with the
Very
arrow
good.
pointing towards.
Uh-huh.
And if it's a slack inequality, it's a filled dot. So it's a completely colored dot.
Fantastic. Very good. Okay, that is nice. That is nice. So that is good, Sidhu. So these are usually taught in 11th class. So I think you are learning at an advanced level. That is really nice. Okay, very good. Good. So we can take up good level of algebra in our discussion there. Good. So, okay, you want to try this?
Oh, yes, sir.
Okay, but you can share your answer. We'll discuss.
Sir, I got x is less than 7, or sorry, less than or equal to 7.
Less than or equal to
7.
7. Okay. So that means then you will start with the open bracket. This is how you would start actually. So open bracket, because less than 7, less than or equal to, right?
Yes, sir.
So then you use a square bracket, and then because you are looking at numbers which are less than 7, you use a minus infinity. This is how you represent. You understood?
Yes, sir.
So let's see. So here, yeah, so that's as it is. And then I'm multiplying both sides by 4. Okay, so if you multiply both sides by 4, then, okay, I think I made a mistake, isn't it?
Yes, sir. The left-hand side.
So then I should have a 4. Then I think you could be correct. My answer will be wrong. So then I should not push forward. I should solve it here. So then what will happen here? So this 4 disappears. So we have 7 minus 3x less than or equal to. So 4 gets inside, that is 2x, and then minus 28. And then this 2x comes to the left-hand side. So minus 3x minus 2x. We can send 7 to the right-hand side. So minus 28 and minus 7. So what do we have here? Minus 5x is less than or equal to minus 35. Okay, now we are dividing by what number? Negative or positive number?
Negative, sir.
Negative number. So whenever we divide by a negative number, which number are we using here?
Minus 5.
Minus 5, right? So that's a negative number. So what should happen to the inequality?
The sign flips.
Sign flips. Okay, so sign is less than or equal to, so now it will become greater than or equal to. You follow this?
Yes, sir.
So then what would happen? The left-hand side, I think you are left with x, and the right-hand side you are left with 7. So then what should be your solution set?
Any number greater than or equal to 7.
So then you should actually represent this by first listing 7, including 7, and infinity, plus infinity.
Oh, I'm forgetting to switch the sign. I should not do that again.
So it's very, very important to flip the sign whenever you are dividing by negative numbers. Understand, Sidhu?
Yes, sir.
Okay, great. So let's, okay, I think I'll pause because I don't
Sir,
want to show you the wrong solution. But
sir, quick question. What
yeah.
I have done is, when I got to the point minus 5x is sorry, minus 5x less than or equal to minus 35. I just cancelled out the minuses because it's on both
No,
the sides and
because
then divided.
what happens is, let's understand it this way. Okay. Now you agree that do you agree that minus 5 is less than, do you agree that minus 5 is less than minus 35 or greater than?
It's greater than, sir.
Greater than, right? So minus 5 is greater than minus 30. Suppose you are dividing by minus 5. Let's say, for a moment, let's say you don't do anything with the inequality. If you divide by minus 5, what do you get on the left hand side?
Positive 7.
1, right? What do you get on the right hand side? Minus 5, 7. Now is
Oh,
1
positive 7,
7?
yeah. No, sir. 7 is greater.
That is why we flip the sign. Whenever you are dividing or multiplying by a negative number, both the sides of the inequality, you have to flip the sign of inequality.
Understood, sir.
Catch the point? Okay. Okay, so we'll slowly walk through it. Okay. So here, I think you need to be careful here. This entire fraction, from this entire fraction, you are subtracting 2. Okay. So there, when you do algebra, you have to be careful. So what I'm doing here is, say, okay, so this is the starting point. Because you have 3 on one side in the denominator and 6 on the other side, conveniently we can multiply by 6 both sides, right?
Yes, sir.
That's okay? Fine, Sidhu?
Yes, sir.
Okay, so now on the left hand, because you're multiplying by a positive number, 6, you don't have to flip the sign of inequality. It remains the same, inequality sign. Now on the left hand side, if you see, 3, I think, divides 6 into 2. Okay. Now on the right hand side, you can take 6 inside. Okay, so this 6 in the denominator goes away, right? And then 6 gets multiplied with 2. You understand?
Yes, sir.
So here, what do we have? Now 2 is distributed inside. So because 2 is distributed inside, you have 6x minus 10 less than or equal to. Now I don't have this, what do you say, 6. I have x plus 1 minus 6 into 2. Okay, so that is 12. You're
Yes,
okay
sir.
with this? This is 12. So 1 minus 12, so that is minus 11. And then this x can be brought to the left hand side, and then minus 10 go to the other side, it will become plus 10. So I have 6x minus x is less than or equal to minus 11 plus 10. And then here, if you see at the top, I'm continuing. So 5x is less than or equal to minus 1 because minus 11 plus 10. Now I'm dividing both sides by 5. Again, this is a positive number. So the inequality, the sign of inequality remains the same. So x will be less than or equal to minus 1 by 5. Okay. So if you are using interval notation, this is how you represent. X belongs to minus infinity till minus 1 by 5. And I'm using a square bracket here to say that minus 1 by 5 is included. And if you're asked to represent it on the number line, I think, yeah, this is slightly less than 0. Okay, so minus 1 by 5 is minus 0.2, right? So it will be somewhere here. So that is your minus 0.2. And then any number which is less than minus 0.2 will be part of the solution set. Okay, so you understand, Sidhu?
Yes, sir.
Okay, so you figured out where you went wrong?
Yes, sir.
Okay, yeah. Okay, so we'll continue.
Yes, sir.
Okay, so now try this one. Okay, so try this one. Very good. That is correct. Okay, so the number of samosas sold in the first 6 days, if you add all of that, you get 950. And then if n is the number of samosas you must sell on Sunday, So it will be n plus 950 should be greater than or equal to 1200, and then yeah, minimum number will be 250. Very good.
Sir, I just literally subtracted 1200 from
That is
950.
okay. That is okay because you are assuming equality, right? Because at least 1200. So yeah, that is fine. Yeah, yeah. But again, I mean, if you are showing this work in a, let's say, school homework or school exam, then you should write clearly.
Yes, sir.
For SAT, yeah, we care about the answer options. We'll see. I mean, as we move along, because you have a lot of time, right? I think for some of the problems we will see, we don't really have to solve the problem. By looking at the options also, sometimes we can answer the problem. Okay.
Yes, sir.
We'll see such strategies. But right now, I don't want you to do that because you're too young and then you're brilliant. So you should learn properly. Okay, so try this one. Okay, so here again, you can say that n be the number of sweets. What is that? He ate. Sorry. Typo mistake. Yeah. So he ate on the first day. And you can write it this way, right? So the next day it will be n plus 2, right?
Yes, sir.
So n plus 2. So we have like 2n. The 2 goes to the right hand side is less than 38. So n is less than 19. And then n is greater than 16, isn't it?
I did not understand the last part, sir.
Because it is given in the, let's say if you look at the, it is given in the problem. It is known that this number is greater than 16. You understand?
Yes, sir.
So that means your n is actually between 16 and 19. Agreed?
Yes, sir.
So then your n will be what? 17 or 18. So what will be the answer then? 17 or 18? Both.
Could be both.
Okay. You want to think about it? Like, is it a problem if, I mean, would it do anything to the data given if you take, let's say, both? Okay. So the correct answer is only 17. Why do you think 18 is not the answer? See, if he eats 18 on the first day, how many will he eat on the second day?
2 more. So 20. Oh, yeah.
20, right? But
Yes, sir.
is it a problem?
But he eats only 38 if we add that up.
Only 38. So that means that is okay, right?
Yes, sir.
17 is also okay. So this is not correct, right? So 18
Yes,
is
sir.
also okay. Then what else is okay? Is 19 okay?
Yes, sir. That 9. Wait a second.
Is 19 okay? If he eats 19, then is it okay?
Well, I'm trying to add in my mind, sir.
Okay, so 19, and then he eats 2 more, then what will happen?
That would be exactly 40, so no.
That will be exactly 40, right? So this is not okay. So 17, 18, both are okay. Okay. So the answer will be 17 or 18. Understand?
Yes, sir.
Okay. So I think